Alright, this video we're going to cover the second part of activity 2-1, questions 3 and 4. So I've taken a picture and pasted it in Excel so we can see the data here. Question 3, graph the data, graph the percent signal on the x-axis and the pressure on the y-axis. What dynamic characteristic is illustrated? In the book it just says nonlinear because this isn't a straight line. But there's a better way to do this, and I'm going to show you that. Plot the data in Excel and then use built-in functions in Excel to fit the data and display what's called R squared, which is a goodness of fit. If R squared is equal to 1, that's a perfect fit. R squared of 0.9 or less, not so good. R squared of 0.1 or 0, no fit at all. Alright, so let's go ahead and do that. So I'll just make some columns here. I can't use these numbers because that's a picture. Excel doesn't see that as a number. Signal, temperature, 0, 10. With the big cross, select both those. I'm holding the left mouse button down. Let the left mouse button up. Okay, next thing you want to do is come over here and get the small black cursor and drag down till we get to 100. There it is. And I'm just going to quickly type in all the numbers here. And we are going to use an XY plot again because there's no reason to use anything else when you're working with data. And you might as well just get really handy with one of them. If you want to try one of the line plots, whoops, that's 125. Or a different type of plot, be my guest, that's fine. Alright, so let's go ahead and go up to Insert. And here are all of our choices. We could click on this and it'll show us all the different choices we can make, all the different plots. And we could just come down to XY scatter and click that. That's what we want. We'll say OK. And let's put it over here. And it doesn't need to be big, so let's shrink it. Now I'm going to right click in there and I'm going to select the data, and the other way to do that is to come up here and select data. So select data, we'll go to add a series. Now you could click a data range here, but I like to add series. It just gives you a lot more control. So series name, I can click in that box. Now X series, well that's these ones here. And Y series, that's these ones here. And there we go. We've got all the data and we say OK. Okay, we're ready to go. And if we want to change some things on the layout, we can add titles to it. Horizontal axis title is percent signal. And primary vertical is temperature. So you can click here in the formula bar and enter it, or you can click in here. We've got all the data. I can right click on here and I can go Format Data Series. Have no fill, and let's make it built in. Let's make them squares. Call that OK. Okay, so there's our data. And I'm going to scoot this guy over a little. Let's make this a little bigger so we can see what's going on. So we've got the data. We've got a nice graph. And we want to know if this is linear or nonlinear. And we're going to use some built-in functions in Excel. So all I have to do is hold the cursor over one of the data points. Oh, and look at that. It also tells us that's x equals 100, y equals 150. There's x equals 70, y equals 100. It tells us all the data. We could tell it to call those out if we wanted. All right, let's see if it's linear or not. So I'm going to right click on one of these data points and a menu pops up. Delete, no. Reset, no. We're not going to do any of these things. We're going to add a trend line. That's what we're going to do. Now we have a bunch of choices, and what Excel is going to do is it's going to try to fit the data a straight line. You can see that the line's highlighted there, the checkbox. There's other options. We want to fit it to a straight line because we want to know if it behaves like a line, and you can see that it's already put a line on there for us. Display the equation on chart, display the r-squared value on the chart. Intercept to 0. So we're going to force it to start at 0. We're going to say, okay, close that. The book says nonlinear, and it doesn't look like it fits a line very well. But when I go in Excel, it says r-squared's 0.96, and that's not too bad. That's some scatter in the data. And if somebody's asked you to say if something's linear or nonlinear, there's always degrees of gray there, and how are you going to know the difference? If somebody gave you some data and said, is this linear or nonlinear? Well, r-squared is 0.97 or 0.96. That's a very definitive answer. It tells you how close it is. Or if I said r-squared's 0.9, you'd say, well, sort of linear, but there's a lot of scatter in the data. If r-squared is nearly 1, you'd say, oh wow, that's really perfect data. And we could prove this. Let's just go ahead and let's just make another series. We'll start at 0 and we'll end it at 1. Let's see, how much do we want to go up by at a time? Probably 15, right? Let's try that. I'm going to highlight both those and go up. Now if I plot this and fit to it, it's going to give us a, I'll go ahead and select, add another series. We'll call this perfect data. This isn't part of the exercise. I'm going to reuse the percent signal over here so I can still use that same x-axis, and I'm going to put in my perfect data. And I'll say, okay, there it is. And there's the fit to the data that we gave it. Now I could fit to this data. Let's go add a trend line to that. And let's just display the r-squared on there. Well, now r-squared's 1. So that's what I'm talking about. And you can see if I change one of these, let's say this one's 135. Let's make it 130. R-squared, still very good. We just got one data point a little out of alignment. And you can mess with this. I encourage you guys to mess with this. So if I had one bad data point, it's still fitting pretty well to the line. See that? Okay, well go ahead and go fiddle with this, and I hope that adds to your level of understanding. And the main thing is we got to show everyone how to build XY plots using Excel.